So Hamza, let's do a quick review over this lesson. Was talking about electricity. You guys, and you know that electricity is very important because without it, we will have nothing working around us. We'll never have any of the devices around us, right? No Wi-Fi. Imagine life without Wi-Fi. It will be cool, but we still need it sometimes. Yeah, so electricity is very important, as we said. And electricity has two types, if you remember. We learned about the series circuit, the one that builds up on objects. Remember that?
Yes.
And we had current electricity. Did I say static or series electricity? Yes, I can't hear you.
Yes.
I just said series.
You said series.
Yeah, I meant static electricity. So we have two types of electricity. You have static electricity and series electricity. Static is the one that builds up on objects, like what your friends did during one of the online sessions when they started making, electric charges using their comms and plastic objects and attracting some paper pieces. And then we have current electricity, which is the electricity that flows through wires, the one we use in homes, okay, to make devices work. Of course, we can't use static electricity because it's not so powerful. Then we learned that the current electricity has two types, if you still remember. It has a series. The current electricity must walk through two types of circuits. What is a circuit? It's the path electricity takes. So if you looked at this picture, okay, it's showing a simple delivery path, like one man taking an order from a pizza place, and he's walking only in one path, as you can see, okay? This path, the electricity is taking, I want you to imagine this man on a motorcycle as the electricity, all the electric charges. As he moves through the circuit, that means it's like the current electricity moving through the circuit. So what is a circuit again? It's the path the electricity takes in order to move through. It needs wires, it needs a bulb, batteries, which is the source of electricity. And if we have any gaps in the circuit, do you think it's going to work?
No.
No, yes, thank you so much. Okay, then we learned that there are different materials that conduct electricity or allow electricity to move through, like metals, salt water. Remember that?
Yes.
Other materials are insulators, or we can say they don't allow electricity to move through them. And those are like plastic, wood, glass, okay? Then we learned that switches in the circuits controls the circuit, okay? So in here, for example, you can see that when I switch off, this is when I switch off. You can see that there is a gap now in the circuit, so that's why it's not going to work. But when I switch it on, what do you see?
No gap.
No gap, so the electricity is going to work now. Electricity will move through. But in here, it's still moving, but if I had a gap, it will not be able to move, okay? Okay, as we mentioned this before. We have different types of circuit, as I mentioned. We have parallel circuit and series circuit. The series circuit, we can say it's a simple one, the one that contains only one path for electricity to move through, like this man walking or driving its motorcycle through only one path. This circle with an X represents, what do you think the circle with an X represents? Does it represent a bulb, a battery, wire? What does it represent? This circle with an X in.
This represents a bulb.
Bulb, yes. And the one line and one tall line and one short line represents
battery.
Batteries, yes. And other lines are representing the wires. So as you can see here, we have this simple circuit. We have A here. Those you guys learn about it later. But as you can see, this is a really simple one with only one path, so only one line. As electricity moves through it, if any gap happens or something is broken, it's not going to be able to work, right?
Yes.
Yes. So here it's walking. The electricity is moving. It moves from the negative, which is the small one, to the positive. So it's walking, walking through the wires, walking through the wires, walking through the wires. But if I have anything that's broken, for example, this bulb just broke down. Okay. In this case, now I need to take all
Okay.
those off, all the wires off. So when electricity will try to move through it now, now it's moving, moving, moving. Yes. And here it will be blocked by the gap, right? Cannot move, can't move because
Yes.
this one is broken. So in this case, this whole circle is not, I'm sorry, this whole circuit is not gonna work anymore because there's a gap in here. Okay?
Okay.
Okay. That's why we can't use series circuits in homes. I mean, imagine if the TV broke down. Everything will break down, right?
Yes.
Yeah, so we need parallel circuits for that. Okay, let me take this off. So we need parallel circuits as I mentioned. Here, for example, this is a parallel circuit. Obviously, we have a bulb. So you have a bulb, a battery, and everything. Now let's try to see what happens when it works. Okay? Okay, so we're having the electricity moving through it. When it comes in here, it will go in two directions, this direction and this one, right? So it will light all those, combine in here, and get back to the positive charges. And how this is, it's working, right? It's working this way. Two bulbs are gonna work and light up. Okay, now let's imagine that again, one of the bulb, for example, this one, broke down. What will happen? Let's see. Let's follow the light again. It will move like this. Yes. Well, in here, he will be blocked by the gap. So he can't walk in this direction. So it will continue walking and it will light this bulb in here and continue till it reaches the last point, right? So in this case, only this bulb is going to work. This one is not going to work, right?
Yes.
So if there is a gap in the circuit, somehow the circuit will still be working. This is the same circuit we're using in homes. This is called parallel circuit. It's called parallel circuit. Can you see the word parallel up there? Parallel circuit?
Yes.
Yes, so this one is the one used in homes. What is the difference between the series circuit and the parallel circuit? It's that the series circuit has only one path. Just let me clear all these drawings. Yeah, so the series circuit in here has only one path for electricity to move through, while in the parallel circuit, we have many paths to move through, okay?
Okay.
Okay, I hope it's not difficult. Okay?
Okay.
One last thing is that with the series circuit, when I add more bulbs, that means the brightness of the other bulbs will actually decrease and get less and less. It will become dimmer, which is not bright enough because the energy of the batteries are actually divided between two bulbs. Imagine if I have only one bulb. Which one will be brighter, the one bulb or the two bulbs together?
Two bulbs.
Two bulbs will be brighter, are you sure? In the series circuit?
No, I mean the one bulb only.
Yes, one bulb, because the energy of the battery is actually divided in here. So, for example, we have two, right? Here we have two batteries. We have two batteries in here. Two. So, one and one. See? So it will be less.
Yes.
Imagine if I only have a circuit like this. Let me show you something. So imagine I have a circuit like this, only like this, and the other pot is not here anymore. Okay? No, I need this one. Yeah, not this one. This one is. Okay?
Okay.
How do you think it's going to work now? It's going to be way better. This 2 will get 2 to this one. So this one will have 2, 2. Okay, so this one will be brighter, not as if it has 2. Okay.
Okay.
Yes. Now let's get to the parallel circuit. In the parallel circuit, it's a little bit different. How is it different? It's different because the energy is not divided. Actually, each bulb gets whatever energy they need. So it's not divided, not like in the series circuit. Both bulbs get same energy from the bulb. So here we have 2 bulbs. This one will get 2, and this one will get 2. Okay?
2.
Yes. So let me clear all this so we can move to some of the questions. Thank you. Okay, so here it's doing a comparison between series circuit and parallel circuit. So here it says bulb brightness decreases as more are added. What do you think?
Parallel? Parallel?
Put it in parallel circuit? Okay, let's check at the end. Bulb brightness constant, it doesn't change as more are added. Like when I add more, it's still constant. It's not going to change the brightness.
Series.
Where should I put this?
Series or no?
Okay, you're asking. I'm actually the one asking here. Do you think that's right, or maybe it's the other way around?
I think it's the other way around.
Yeah, I just know that. Let's check at the end. Okay, so if I wanted to solve this, because some things you guys are not going to learn about, like voltage and stuff like that. So let's solve it. So in here, you can see that the bulb brightness is constant as more are added. Yes? Yes? Yes, Hamza, can you hear me?
Hello?
Hamza, can you hear me? My connection is unstable. Can you hear me?
Yes.
Okay. So Hamza, current divides. What do you think we should put? Where do you think we should put this?
Miss, what is the meaning of current divides?
Current is the electricity moving through the wires. The electricity moving through the wires are called current.
Parallel? Parallel?
Do you think it's going to divide into parallel in the parallel circuit?
No, put it in series.
Yeah, series. If one bulb breaks, they all go out. Where should we put it?
Parallel.
Parallel, are you sure?
I'm not really sure.
Hamza, you're kind of mixing between both. Parallel circuit is the one where if anything breaks down, it's still gonna work because every bulb has its own path.
Okay, put this in series.
We can say that parallel has many passes. So remember it was P. Many passes in parallel. In series, only one. Solo, remember it was solo like S, only one path, okay?
Okay.
The voltage is the same. This one's this thing you're not going to learn about. Battery runs down faster. In which one do you think the battery will run down faster? The one that divides the energy, or the one that gives every bulb the same amount of energy?
The one that divides the energy.
But this one is not using much energy.
Series. Or no?
Where do you think?
Series. I think series.
Okay, we'll check at the end. Bulbs are equally bright.
No.
Where do you think?
Bulbs.
Here or here? We can try maybe here, and we'll see at the end, okay?
Okay.
Okay, can you read the last one?
Bulb brightness constant as more are added.
Yes,
what
it doesn't
is the meaning
change.
of constant?
Doesn't change. It's the same.
Parallel.
Okay. Current is the same at all points in the circuit. I think we should add it here. Voltage is shared. We should add it here. Bulb brightness decreases as more are added.
Parallel.
I think we should add it here, right? In the series. So
because
that means there is a point here that we need to move it to parallel. What do you think?
bulbs are equally bright.
What do you think? Should I move this one? I
Really?
don't know. I'm just asking you. We're trying this. It's okay to make mistakes. What do you think? Should I move this one here?
Bulbs are equally bright.
Should I move it to the parallel, Yani? Is that what you mean?
Yes.
Okay, we'll check now. Let's solve it. Okay, so in series circuit, if one bulb breaks down, all of them goes out. That's right, we did this. Current is the same at all points.
Okay.
This one is, we made a mistake. Bulb brightness decreases as more is added. Didn't I mention in the series circuit in here that if I have two bulbs, that means the energy will be divided over the two bulbs. Remember, if I'm having two batteries, the energy of the two batteries will actually divide over the two bulbs. Remember that. So that's why if I added more bulbs, it would get dimmer and dimmer. It will become less bright.
Okay.
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 But in the parallel circuit, if I added more batteries, it's okay. If I added more bulbs, it's okay. All the bulbs will get the same energy. They will get all the energy. And that's why the batteries in here, because they do not divide their energy, they will run out fast. Not like this one. In this one, the battery actually divides its energy. So it's not going to run fast. But in here, it doesn't divide its energy. It's actually kind of gives all the bulbs the energy they need. So in this case, it will run out way faster. So if we get back here, you can see that battery runs down faster was in the parallel circuit. Bulbs are equally bright, as you mentioned. That's right. Voltage is the same for each bulb. Voltage is something you'll learn about. It's like the power of the battery itself. And then bulb brightness constant as more are added. Like when I add more bulbs, it's okay. All of them will be bright enough, but that will lead the battery to actually lose its power way faster. Okay?
Okay.
So let's check some of the questions here and we'll be over. You don't have to do all the questions. Do not worry about this. So it says that a simple device that opens and closes an electric unit is called. Electric unit is the same as electric circuit. What do you think is the device that controls the electric circuit? Is it?
It's not volt.
Yes.
Or current or discharge. It's gonna be switch.
Switch. Well done. What's going on here? He wants to highlight everything. Okay. Number 2. Lightning is caused by the building up of electric charges in a cloud, also known as static electricity. What do you think?
I think true.
True, yes. When two clouds rub against each other, the ice crystals forming the clouds start gaining negative energy. And because the ground is positive, the negative will move to the positive, causing the light to show up. Number 3, parallel circuits have only one path. True or false?
False.
False. You just learned that they have many passes. The current always travels from the negative to the positive.
False.
It's actually true. The energy or the electric charges always move from the negative to the positive. If I showed you in here, I think I closed it, but in circuits, it's like all the negative charges move to the battery through the wires to the positive side of the battery. You know, in the battery, we have two sides, negative and positive. The negative gets negative charges and they start moving through the wires so they can get to the positive. Okay? Okay?
Okay.
Okay. Number 5, which of the following materials is an electrical conductor? So it's a silver or silver colored plastic or cork. It's going to be silver because it's metal. Well done. And silver colored plastic is cork. Cork, it's like the wood. Something like wood plastic. Yes.
And silver silver color plastic.
Well, this one
It's
is just to
plastic
get you
or sand?
confused. Yes, it's still plastic, but it's just still silver colored. Will it make any difference?
No.
No. Yes, well done. Which of the following materials is an electric insulator?
Insulator.
Mm-hmm.
Rubber.
Rubber, yes, well done. Aluminum and gold are both metals, so they are good conductors. Okay, electric current is a or an circuit travels in more than one path. In what circuit? It travels in more than one path. More than. Series, wire, parallel. It's here more than one path. This is where the answer is.
More than one path. Parallel.
Parallel, yes.
Parallel.
Well done. Why is a bulb brighter when it's powered by two batteries? So I gave it two batteries, and now it's brighter. Why do you think? Because the flow of electricity is in the circuit is less, or because the flow of electricity in the circuit is the same, or is it because the flow of electricity in the circuit is greater now? Bye. Bye.
B.
شكرا يا مازن. Thank you so much. Huh?
B. B. Because the flow of electricity.
It will never be the same because now we have two batteries rather than one. So that means it will be greater. Yes, greater. Yes. Okay. In or an parallel series circuit, if one bulb burns out, the others will stay lit. Stay working.
Parallel?
Parallel, yes, well done. Number 10, which of the following is not a good insulator? Not a good insulator, which means it's a good conductor.
Iron?
Iron, yes, well done. So see, you're getting to it. So Ruby makes a complete simple circuit with one bulb and three batteries. The bulb lights for an instant and then goes out. So she used one bulb but three batteries. And it worked a little bit, but then everything went out. What do you think happened? So not enough electricity flows around the circuit, or it was too much electricity flows through the bulb, or the batteries are flat. She only had one bulb and three batteries, three whole batteries. What do you think?
The batteries are flat?
No, they are working
I think
well.
C.
No, it's not C, because batteries are fine. They're working. It worked for an instant.
B.
It's gonna be B, yes. There are too much electricity. Yes, too much electricity. That led all the bulbs to actually burn down. Okay? When there are too much electricity, the bulbs will burn out. Why is electrical wiring usually made from copper? Why do you think the wires are made up from copper? Because copper is shiny, because copper conducts electricity, or because copper is not magnetic?
It conducts electricity.
Conducts electricity, yes, well done. So the rest of those, I will send it to you guys so we can do it at home, okay? There will be other videos, Hamza, but just let me do this one for you, this last one. This one's showing you circuits that I need you to diagram here, to draw it, but with symbols. So let me get the pen in here.
Yes, I can do it from the computer.
Okay, but I need you to do
it from the computer.
You want to draw it yourself? Now? You want to draw it now?
I can do it on the laptop.
Okay, try it.
I can do it now, but it will show on your screen.
Okay, that's nice. That's way better. Yes, you can try it. It's okay.
Should I draw the same thing on this?
It's okay. Yes, draw it on the screen. You can draw it. Okay. But it needs to be in straight lines. Okay.
Yes.
Okay, Hamza, what's going on?
I am not good at drawing on my laptop.
It's gonna be hard with the what we call it, like the mouse. Okay, so let me do it. Let me do it.
Okay.
I'm gonna show it to you.
Gonna erase it.
It's okay, I erased it. So first we'll start with the pop. So
Okay.
we'll have like a long line and a short line. This will represent the pop. Then we'll have the wire in here. There's the wire. I'm just using different tools from the Zoom, so it's not me drawing this. And then we'll have the switch. Switch is so simple. It's just like two circles, two small circles.
Okay.
Okay, like this, two small circles. I just need to move this. And here, two small circuits. Should move a little bit. Just let me draw the line first. There is the line. And then we'll have another circle in here to represent the switch is on. As you can see, the switch is on. Then we'll have the rest of the wire like this, and then another one like this, and then we'll draw a bulb. A bulb is like a circle with an X in it. Okay, let me get the X. Here is the X. And then we have another wire, and then another wire. Right? And then those are connected together. So this is how simple is it. Do you now get it?
Yes.
Okay. But now I'll have to leave. Do you have any questions before leaving?
No, thank you.
If you have any questions, Hamza, or anything you can't understand, you can send me on the SMS. You can send me on the messenger by your mother's account. It's okay. But just, you can send me anywhere. Okay? Anytime.
Okay.
Okay. See you, Habibi. Bye.
Bye.
Enjoy the weekend. Have a nice weekend.
You too.
Thank you. Bye.
Bye.